Alcohols are organic compounds that have an OH group attached. The OH group can be anywhere so long as it is a branch coming off the main chain. The molecule has an overall polarity going towards the right, and this is because of this highly electronegative oxygen atom that's on one end of it. When we look at the molecule though, we notice that the polar feature from the molecule comes from the end, coming from the OH group, and then the rest of the molecule is nonpolar. Now, because this molecule has a split polar and nonpolar region, we find that its solubility in water is dependent on its size. We say that butanol, which is an organic alcohol that contains four C's in it, is going to be soluble in water because it's overall going to be polar. Anything below butanol, below 4 carbons, will be soluble in water, but anything above is not. So if you were to mix alcohol and water together, if your alcohol contains 5 carbons or above, you'll notice that you'll form a layer upon water. But if it contains 4 carbons and below, it will evenly mix. Naming alcohols is rather straightforward. It's the same rules as we learned before. Everything before applies. Now though, the parent chain or the parent name is going to end in OL because of the alcohol group. Let's do an example here. Here's our first example: CH3, CH, CH2, CH3 with the OH group coming off here. Now the OH group takes priority. We notice that the OH group is located on this carbon here. We're going to try to give that OH group the lowest numbers possible, and that can be achieved if we number the main chain from left to right. So this is going to be 2 because of where that OH group is. This is a organic molecule with 4 carbons, so it's going to be butane, but instead of butane we write butanol. Here is another example. Let's add a branch to it to see how we deal with that. Again, the OH group takes priority, so that tells us that our numbering is going to go from the right, like so. If we do this, the OH group gets number 2. If we had gone the other way, it would have been number 5. We label the branches first. We have 1 methyl branch at carbon 5, so this is 5-methyl. Then we finish it off with where the OH group is. It's at carbon 2. This is a 6-carbon chain, so it's going to be hexane, but we change the ending into ol. 5-methyl to hexanol. Let's add a couple more branches here to increase the complexity of our alcohol. Let's add one of these and one of these. Again, the OH group takes priority, which is kind of nice because it limits you in how many ways you can number the chain. We have to number it from the right so that the OH receives the lowest number possible. Then we name the branches as usual. We have a methyl, we have an ethyl. E comes before M, so we're going to name the ethyl first. It is on position 4, so this is 4-ethyl, 5-methyl, 2-octanol. Alright, 2 more examples. Let's see what happens when we have a cyclic structure like this. OH takes priority, so that is automatically going to be carbon number 1, and 2 is going to be on our branch to keep our branch numbers low. This is going to be 2-methyl. Now, because the OH group always takes priority, if there's only one of them on a cyclic structure, it is automatically assigned number 1. And just like before when we saw the cyclic structures, when something is automatically number 1, we don't write the number down because it would be redundant. So this is called 2-methyl cyclohexanol. Hopefully, as you're watching this video, you are trying to name these things before I give you the answer. Please press pause after you see a structure so you can attempt them. Alright, and our final example here. Let's do something a little bigger. Go. Let's have 2 OHs this time. Once again, alcohol takes priority. We are going to number the chain from the left so that each of these OHs get the lowest number possible. We see that our methyl branch is on number 8. So this is 8-methyl. Then we write down where OH groups are. Now there's 2 of them, so we're going to write 2 numbers down. First one is 3, comma, second one is 5. Then we're going to name the main chain here. This is a, oh, what happened here? 9 carbon chain. This is nonane. Now we have 2 alcohols, just like before when we had 2 double bonds. We had diene, and 2 triple bonds is diene. We have 2 OHs. This is going to be called nona-diol. Once again, that prefix di is occurring right before the structure that is applying to, which is the OL, indicating OHs. Okay? We do not put the di in front of the nona. Di, nona, all sounds like you have 2 chains of 9. So we put that di right in the middle, right in front of the OL to say 2 OHs. And this is how you name alcohols. Go out.